Hello my friends and welcome to this quick revision in your favorite subject, chemistry. This is the class, and in this class we are going to answer the questions we took as homework in the previous class. Before we start answering these questions, allow me to revise the information we have taken in the previous class so that we are going to use them to solve the questions. First of all, we talked about this atomic structure, and we said that an atom is made up of two main parts. The first one is called the nucleus, which is in the center and inside which we can find two types of nucleons, positive protons and neutral neutrons, while the other part into which we can find only negative electrons is called the electronic shells, or we can call them the energy levels. And we said that the number of protons and neutrons inside the nucleus is called the atomic mass. And then we said the number of protons only, the number of protons inside the nucleus is called the atomic number. And after that, we said that although all atoms in the world are made up of the same subatomic particles, but there are group of atoms that call the elements. So what was the element? The element is a group of atoms that share the same number of protons or the same atomic number inside their nuclei, and they go through the same chemical reactions. And we said that the atomic number of an element is like its ID. So all copper atoms in the world have 29 protons inside their nuclei each, while every atom in the world that belongs to the iron element has 26 protons inside its nucleus, and all atoms that belong to the gold element have 79 protons inside their nuclei. That's why elements are different from one another. Then we said that scientists wanted to calculate or measure the mass of the atom, so that they had to put a unit as a scale to depend on. Then we said that because elements are different from one another, it is better for us to know the mass of every element by itself or in isolation. And scientists wanted a fixed scale according to which they can measure the mass of the atoms. So they agreed upon AMU, which stands for atomic mass unit. And they said that one atomic mass unit is equal to the mass of one proton and to the mass of one neutron, which is equal also to the mass of 1,837 electrons. Some books mention that it is 2,000, not 1,837, and this depends on the reference, and both of them are accepted for us. Now, my friends, when scientists wanted to calculate the mass of an element, they said we have to take into consideration only the mass of the protons and neutrons, and we should ignore the mass of electrons in our calculations. The reason of that was because the electron was very, very light compared to the other subatomic particles, so it was logical to ignore it in our calculations. And we said that according to this method, we have, for example, here copper. Copper has 64 nucleons, or 64 protons and neutrons inside its nucleus, so that the atomic mass of copper is 64. For the iron, it has 85 nucleons or protons and neutrons inside its nucleus, so that the atomic mass of iron is going to be 58 AMU, and for the gold the gold atom has 196 protons and neutrons inside its nucleus, so that the atomic mass of gold is 196 AMU. A new problem in this field emerged when scientists discovered something called isotopes. Isotopes are the elements or the atoms of the same element that share the same number of protons, but they have different numbers of neutrons. For example, we have this atom or this isotope of iron, which has 56 protons and neutrons, meaning that 26 protons and 30 neutrons. This one has 31 neutrons, so the mass number is going to be 57, and the third one has 32 neutrons, so the mass number is going to be 58. And the question was here, which isotope shall I use in the periodic table to define the element iron? Shall I say the iron has the atomic mass 56 or 57 or 58? Then scientists decided to take something called the relative atomic mass. The relative atomic mass here depends on the fact that not all of the isotopes of the same element are existed in the same percentage or in the same abundance inside the element. So we should take all of them into consideration, and we should after that take the average of these atomic masses so that we can calculate the relative atomic mass. Now, my friends, allow me to start answering the questions according to what we have just revised. The first question here talks about the magnesium isotopes. Now, my friends, let's answer the question here. As you see, we have many isotopes, 3 isotopes of magnesium. Everyone has its own atomic mass and its own abundance, and we should use this data in order to calculate the relative atomic mass. We use the relative atomic mass equation, which is here. We take the mass number of each isotope and we multiply it with its abundance. The first one here, second one here, and the third one, 26, multiply 10.8. And the answer, of course, it should be taken with the unit AMU again. Now, the second question is theoretical, and it says what are isotopes? Well, isotopes are the atoms of the same element that share the same atomic number of protons in their nuclei, but they have different number of neutrons, which make every one of them different from the others in the mass number. Question number 3. This is a chart of subatomic particles. We need to write their relative masses and their relative charges. In here again, I have this notice here that the electron's mass is 1 over 1837, but in the IG and the AS books, in the British syllabuses, it is mentioned here as 2000, but it's not a problem for us. So the proton here, relative mass is 1, neutron 1, which is equal to 1 AMU, and for the charges, a proton is positively charged and an electron is negatively charged, and the neutron is neutral, or we can write 0 here, it's not a problem. But again, my friend, it's a neutral, and we cannot say that the neutron is not charged. The neutron is generally like the atom. The atom is neutral because it has positive parts and negative parts, and the positive parts and the negative parts inside it are equal. Now, my friend, let's answer question number 4. In here, question number 4 has the same principle of question number 1, and we only need to write the mass number of each isotope, and we multiply it with its abundance. And here, 22 multiply 8.80. course, on 100 and calculate them. After we calculate them, we take their average, and the number here is not important for me. The most important thing is to understand the principle and to know the unit, which is AMU. Finally, my friends, we answered the question number 5 and we finished this class. In question number 5, we need here to calculate the number of protons, number of electrons, and number of neutrons. Before I answer this question, I would like to remind you that I have made 2 Kahoot games which are related to this topic to calculate the number of protons, number of electrons, and number of neutrons inside every atom. Now, my friends, here we have number of protons, which is the atomic number, always written here, lowercase to the left, all of them magnesium. And here we have number of neutrons, doesn't change also, 14. Let's try to play a game here. For example, let's say this is 27. So here it is going to be 26 minus 12, 14, 27 minus 12, 15. And let's write here 29, for example. So here 27 minus 29 minus 12, which is here 15, and here 17. Now let's calculate the number of electrons. Your number of electrons is Z minus B. Here B is 0, so that we have 12. Here it's 12 minus plus 1, so it is 11 electrons here, and here 12 minus plus 2, not minus 2, plus 2, and it is 10 electrons, and those are called positive ions, or we call them cations. That's it for today, my friends. Thank you for watching this video, and again, if you don't understand, please try to replay this video again and try to play some Kahoot games which were made especially for you to practice this topic and which are related to isotopes on my profile. Thank you so much again, and I wish you all the best. Please try to study hard and get high grades. Thank you and goodbye.